Jim Shaw here from Crystal Group, and we'd like to focus this podcast today on power supply and power supply design and development here at Crystal Group. I am honored to have with me Mike Steffen, Jeff Toccacelli, and Mark Howe. Today we're going to talk a little bit about how Crystal Group got into the power supply design and development and why it's necessary in our business. And I think to do that, we need to focus a little bit on the verticals that we serve in this particular business. And we have essentially our main rack-mounted unit types of power supplies. We have commercial, automotive power supplies. We have industrial, smart grid types of power supplies. We use embedded power supplies for particularly embedded small form factor devices, and we also do quite a bit of networking power supply development. So, that's kind of the way that we got such a broad portfolio of power supply designs, is we serve a lot of verticals in the market, and in order to meet the customer's needs, it's become apparent that we have to be able to design and develop supplies to be able to satisfy those demands. And that's one of the challenges with this particular industry. And so I guess I would like to turn it over to you, Mike, and ask the question, what is the Crystal Group philosophy in terms of power supply design and development?
Well, the answer to that is simple. It's the same philosophy that we have for product development as a whole. Our niche in the market is ruggedized COTS. So if we can buy it and if we can make it work, we will do that. There's a time to market benefit to doing that. There's a cost benefit to doing that for the customer. So we will go to ruggedized COTS where we can. Unfortunately, power is one of those areas that just doesn't always work out that way. The requirements tend to be very niche and very difficult to meet. Electromagnetics is hard to meet with commercial supplies. Power quality, some of the aircraft and ground vehicle power quality requirements are very hard to meet with commercial supplies. So in those cases, when those requirements come up, a lot of the times we have no better choice but to go to a customized solution.
Excellent. What kind of methods does Crystal Group actually use to ruggedize power supplies in terms of front-end modifications or features that you normally wouldn't find, Mike?
Well, we do a number of different things. For a ruggedized COTS unit, we, of course, will do staking and conformal coating for meeting vibration and shock and humidity for applications that need that. To meet electromagnetic compatibility requirements, we'll often put a custom filter board or a custom transient protection board or some additional circuitry in front or behind the power supply to meet those requirements, if we can do that, because that tends to be a less impactful design than going full up custom.
Mike, you mentioned that there are several different vehicle markets here, and I know that MIL Standard 704 is airborne, 1275 is essentially ground vehicle. We've got requirements for 461 and DO 160. When is it appropriate to use COTS, and when is it appropriate to really apply a truly custom solution?
We have the most difficulty with finding appropriate commercial power supplies, ruggedizable ones, in the 28 volt, either ground mobile or aircraft market. There's not a lot of commercial viability for 28 volt equipment, and so there's not a lot of commercial demand driving development from the major power supply manufacturers. So whenever 28 volt comes up as a requirement for the platform, that's when we usually start looking at custom power supplies. The requirements are harsh, the commercial options are not there, that tends to make the most sense there.
Yeah, I've noticed that we've used quite a bit of for 704, particularly some capacitive hold-up boards to basically pass through the 50 millisecond hold-up requirement, and that's just one common approach that we use, and in order to augment the capabilities. Are there other things that we do traditionally, Mike, that help us meet the customer's needs in terms of specific power requirements?
The 50 millisecond holdup is a good one. That one comes up quite a bit and is one of those requirements that's really hard to get in a commercial power supply. 28 volts is where we often see that, but we also have quite a few applications where we're doing that at 115 volts, 400 hertz. Same aircraft requirement for bus transfer from shore power to aircraft power. That comes up quite a bit. In a few applications, we are working with poor power quality. Substation market is a good example of this, where the power is very noisy. You get huge spikes because of the huge nearby switching in the switch yard, and so in those applications we have enhanced transient protection on the input of the power supplies to try and eat some of that excess energy that's around on the lines. But our most common augment to a power supply is the input filter for EMI reasons.
What about surge suppression?
Surge suppression, yeah. The smart grid applications is a huge area where that's a problem, as well as in the automotive market, where automotive power tends to be very noisy as well from the large engine components. So again, in those applications, enhanced transient protection, extra filtering on the input of the power supply, active protection, active transient protection. These become important when you're trying to prevent the vehicular power environment or the aircraft power environment from causing adverse performance on your system.
Mike, you mentioned essentially the automotive market as being one of those challenges, and I know that we've got the world's only 2,500 watt DC 12 volt supply. Would you like to talk a little bit about the challenges associated with putting that together from your team?
12 volts is a difficult area for power supply design. It's very high current, it's very high power. The systems that we're putting these power supplies in are some of the highest power density systems that we make. The 12 volt area is really focused on 12 volt automotive battery source. So these systems are typically deployed in autonomous vehicle applications where the power source is a 12 volt battery powered by a 12 volt alternator from the engine. So it's noisy power, it's a ton of current, it's a ton of horsepower because of what's required by the autonomous customers. So all around, it's a very challenging environment to deal with. So we had to go to great lengths to develop a solution there that not only met the immediate requirements for very clean power, very high power, but also for expandability, as our customers have continually needed more and more compute power to explore the new areas of the autonomous trucking or autonomous transportation markets. So we actually forethought to put hooks in for expanding that platform as well, and so we can go from our 1,500 watt solutions there to 2,000 to 2,500 to 3,000 watts even is on the map to support future requirements for that platform.
That's great. That's a lot of current. That sounds like that could be a thermal challenge. What did you do about that?
It certainly is. And on these platforms, thankfully, a lot of the time we have chill water or we have coolant water available to us. Because of the density of the solution, it's really difficult, if not impossible, to cool a system like that in the volume of the systems that we're providing without a water solution. There's not enough space for air in the system, and so we usually have coolant available to bring the heat out of the system. But the power supplies are very efficient. It's a huge amount of current, but really not a lot of waste heat. So the loss from the power supply is a very small portion of the total loss of the system.
Very good. I'd like to turn the conversation now to Mark Howe and ask a couple of questions about brick use and what we would call a semi-custom power supply development. And Mark, can you tell us a little bit about why we use bricks and what the advantages of those particular bricks are with respect to developing the supplies?
Well, bricks are handy because oftentimes we run into situations where the form factor of a COTS power supply just doesn't fit it. Now, Michael was just talking about this monster power supply we have that's water cooled. Well, that's a big brick-based supply also. And the bricks are something that is a standalone item. It's a standalone power supply. It has sometimes its own agency compliance testing completed on it. They're more expensive than a total custom solution, but we can take these bricks and we can quickly turn a power system that meets our niche requirements for this design. And we've found that we've been able to leverage multiple bricks, single bricks, and anything from a small embedded design to a big water cooled design. We've put these in there because many times these bricks even have current sharing capability built into them, and ones that don't, well, we have circuitry to do that ourselves also.
Bricks give you two things, flexibility and speed. And then a lot of those particular rail requirements are already driven into the bricks. So
Absolutely.
you've got kind of a known good starting point. So really, when you utilize these bricks, how do you tie them together, Mark?
Well, some of the bricks have front end current sharing, some have back end current sharing. We'll lay out a PC board to take advantage of those features. Matter of fact, during our current supply chain issues, we took some of our boards and drilled them out a little bit, and we were able to use multiple brick manufacturers to make roughly the same supply.
So again, it's one of those flexibility issues, and you can actually make changes based on supply chain issues to the design here in-house.
And we put our own front end circuits on because oftentimes the bricks don't have all the filtering they need. But we have some drop-in filters that we have had a lot of experience with. And sometimes we reshape the filters to fit the form factor. Matter of fact, I'm working on one of those right now. And we also have some active clamping circuits that we put on the front to meet certain specifications that are required.
Okay. Maybe we'll ask Jeff a question here about fully custom designs, and from that we kind of mean discrete component based designs. When does that make sense, Jeff? And what are some of the advantages of having all of that design content in your bill of material?
Well, it makes sense when, like, say you have a form factor that you can't solve with a brick-based design, because bricks come in a very specific form factor, whereas a discrete design, you have a lot more flexibility because you're building with the individual transistors, inductors, diodes, and you can form your design to your liking depending on the shape of the design. Also, you do have pretty much ultimate flexibility with a discrete design. Because again, with supply chain issues, you're not at the mercy of a brick manufacturer. You can actually go out and spec multiple transformers, transistors, diodes. So you have multiple sources to get a design built. And you can substitute these parts as you need them based on supply chain issues. The other flexibility is, for instance, like EMI testing. You can lay out the board exactly how you want to lay the board out. You can incorporate self-shielding based on how you stack up the layers in the board. You can also pick exactly what the switching frequency is, so you know exactly where the outages can be, and you can design your input filter accordingly. So your input filter is not like a separate front end, it's incorporated in the discrete power supply. Oh, also the control loop. So you have access to the feedback control loop. So basically you just have a lot of levers you can play with. So you can really customize the supply exactly how you want it.
Excellent. And one of the things that we've experienced, especially in 2021 and 2022, is there were some supply chain hiccups, specifically with bricks, and we were in a good position to be able to respond to that. I think that's probably worth mentioning there. One of the things that we've been working on lately, and maybe I'll get you to comment on this, Mike, is PM Bus in terms of the software development for managing the power supplies. Would you like to say a couple of words on that?
Yeah. So PM Bus is a industry standard communication mechanism that's initiated by the motherboard that can interrogate the power supply and figure out operating voltage and temperature and fan speed and so forth. And the major reason that you would want that sort of thing is for reliability reasons. You want to know how hot your power supply is, whether the fans are operating or whether there's a problem, so that you can do preventative maintenance and not have a downtime operation when you really need it. So a lot of our commercial power supplies are starting to show up with PM Bus support, and a lot of our custom stuff is we're seeing a lot more requirements for PM Bus show up, so our custom designs are starting to roll that in as well.
Mike, can you tell us a little bit about qualification testing and proving design and verification and validation in terms of power supplies? Can you talk a little bit about what your team does?
Yeah. The most important thing is the power supply has to provide the power that it's rated to put out. So every one of our power supplies goes through a rigorous set of load testing, load step testing to make sure that the supply is designed and rated for what we say it's rated for, even at the corners of the operating curves. We don't underspec stuff. We run it all the way out to the corners and make sure that it doesn't have a spot where it's got a vulnerability. Make sure that it can do the huge load steps that are starting to show up for ATX 3.0 and for the larger NVIDIA GPUs that are showing up now, where they might hit you with 50 amps of burst on a GPU. And we want to make sure that everything stays within regulation, within spec during those times. We don't want to have an excursion outside of the ratings on the cards, causing damage to any components. Often we'll see requirements levied for electromagnetic compliance. So we will do radiated and conducted emissions testing on a huge number of our supplies, maybe all of them.
Seems like all of
them. Just to get a baseline for how bad they actually are, and B, if there's a particular customer requirement that's levied, say Mill Standard 461, CE 102, or RE 102 ground mobile as a particular limit line. So we'll run it to that limit line, and we'll make sure that we don't just put 461 on the box, that we actually meet the particular requirements that are called out. And the good thing about doing a lot of this design in-house, as Jeff has talked to and as Mark has talked to, is that if there's a problem in one of these areas, we have the IP and we have the knowledge to fix it. We can tweak values. We can add components. We can subtract components sometimes. So because we have the engineers in-house that are doing the designs, that are then testing the designs and seeing the results immediately and having their hands on the product, we can really turn around some innovative solutions for noise problems and for qualification problems that we wouldn't have the ability to do if we did not have the engineering expertise in-house.
That's great, Mike. One of the things I would compliment you on building a strong subject matter team in terms of the power supply design and development. That's quite an accomplishment, and I think that it really speaks well to Crystal Group's capabilities. Where do you see the future state of power supply design going for the company in terms of next gen?
Sapphire Rapids has got a maximum CPU of 350 watts. We're seeing 350 watts in GPUs now, and they don't. Customers don't just want one; they want 2 CPUs. They want 4 GPUs. They want as much as we can pack in the boxes as we can. We're going to have to support that, and so our solutions have to become not only cognizant of that, but also I would say more modular. We have to go back to the approaches that we took for say the AVC or for the autonomous line that we talked about earlier for the 12-volt application. We have to be able to scale from say 1,000 watts to 2,000 to 3 to 4 to 5 in a way that makes sense for the platform. It's hard to do that all in one whack, right? In one giant supply, but it's much easier to take and make it in pieces to be able to basically Lego your solution up to the size it needs to be. It's quicker to market that way. It's easier to develop that way, and that has a cost benefit as well. We're also looking at some more exotic technologies. As the power levels have gone up, the necessity for efficiency have gone up as well, because your losses from the power supply scale with the size of your power supply. So new and exciting transistor technologies, silicon carbide, gallium nitride. These are going to be important technologies as well with some of the new power supplies we're working on. Just because we need the efficiency out of them, we need the size, we need the efficiency, we need the power. Great
comments. This has been a great discussion, guys. I guess is there anything that you'd like to add to this discussion that I didn't? You wished I'd asked you a question I didn't, or anything that we didn't cover you thought was good, Jeff?
Yeah, I'd just like to point out that because it's unique to, I think, to Crystal, where the engineers are the ones that actually lay the boards out. We don't have a drafting department.
Yeah.
So it's very beneficial that engineers are actually laying the board out, because we understand how electricity works in a board. A drafter does not.
Yeah. Well, hey, thank you very much for spending some time with us, and thank you, podcast listeners, for tuning in and hearing a little bit about Crystal Group and power supply design and development. If you have any questions, please contact us at www.crystalrugged.com. Thank you very much.